morning class. Today we will be learning on the topic domain and range of a function. So, domain and range of a function and range of a function. First, we will learn about what is domain. Domain. Consider a function f defined from set A to set B. Okay, now here set A is called the domain of A, called domain of A. Okay, now we'll go through about the actual definition of domain. Here, domain is said to be all the inputs that we give to a function which makes the function a well-defined function. Okay, now take example we'll write the definition now. The inputs which the inputs which we use to define a function is called domain. Here, inputs which we give to a function must be given in such a way that it defines the function well. For example, take a function fx is equal to x. Okay, fx is equal to x. Here, to find the domain of this function, we'll see that whatever value of x we put here, it will define the function. It will not make the function undefined. Okay. See, if we take the value of x as all the real numbers, is the function defined or undefined? Here the function will define because it will give us the actual value of the function. So here domain of this function is set of all real numbers, because see, if we put the value of x as take any value of x, the function is always defined f of x. If we take in place of x as 1, we'll get f of x as 1, f of 1 is 1, and f of 2 is 2, and so on. Okay, so the domain of this function is set of all real numbers. Now we will do some examples on domain. Okay. So our first example will be let's take a function fx is equal to 1 by x. Find its domain. here. See, is the function well defined for every value of real numbers? See, if we put the value of x as 0, what will be the function? If we put the value of x as 0, f of 0, 1 by 0. Is it defined or undefined? Here we see that the function is undefined. It is undefined. So here we see that if we put the value of x as 0, the function is becoming undefined. So here we find out that the domain will be equal to set of all real numbers except 0. Okay, are you clear? Here the domain will be a set of all real numbers except 0. Okay, now we'll do second example. Second example, we'll take a function fx is equal to under root of x minus 2. Okay, solution. Here we see that under root of x minus 2. If we get negative number under the root, for example, say negative number under the root, will it be a real number or a complex number? It will be a complex number. Complex. But in this case we are dealing with real numbers. In this case we are dealing with real numbers. So we will not consider negative, will not take negative under the root. Therefore, here function fx is defined when x minus 2 is always greater than or equal to 0. Okay, if we take x minus 2 always greater than or equal to 0, we'll always get positive values under the root, which will define our function. Implies that here x will be always greater than or equal to 2. Okay, so the domain of this function will be domain is equal to close interval 2 to infinity. Okay, every value which is equal to 2 or greater than 2 will be the domain of this function. Now we'll do one last example. Third example, fx is equal to 1 upon sin x. First of all, let us check that is this function defined or not for all the values of x. So let us see that sin x. Here only the thing which will disturb us is the value of sin x. Sin x should not be equal to 0. Okay, sin x function fx is defined when sin x is always greater than 0. Sin x, when sin x does not equal to 0. Okay, sin x should not be equal to 0. So here we have to see that sin x does not equal to 0. sin x does not equal 0, we have to find out that when sin x becomes 0. Sin x equal to 0. When it is 0, sin x equal to sin 0. Okay, or x is equal to 0. When the value of x is 0, we'll get sin x as 0. And in general the values of x can be the values of multiples of pi, n pi, where n is any integer. Okay, so now the domain of this function will be domain is equal to all the real numbers except 0, or all the real numbers except the multiples of n pi. Okay, now we'll understand our second topic, which is range of a function. Here, by the word range, we will understand what is range. Range is all the outputs of a function. For example, if we take a function fx is equal to x, here, to find the range of this function, we'll consider y is equal to x. Okay, y is equal to x. Now here y is equal to x. Here range is also called the range is also known as image of a set. Okay, now we'll deal with the definition of a range. Here, consider a function. Consider a function f defined from set A to set B. Here, range of the function can be set as the elements of set B, which has a pre-image in set A. Okay, is the definition clear? This means that the elements of set B, every element of set B which has a pre-image in set A is said to be a range of that set. Now let's understand this with a short diagram. Consider a set A to be 1, 2, 3, 4, and set B to be A, B, C, and D. Okay. Now see that this is a function. One has an image A, 2 has an image B, 3 has an image C, 4 has an image D. So here the range of this function will be equal to set B, because here we see that every element of set B, set B, which is A, B, C, and D, has a pre-image in set A, which is 1, 2, 3, and 4. Okay. Therefore, range of this will be set B. Okay. Or we can write it as range as A, B, C, and D. Okay. Is it clear? Okay. Now we'll do some examples related to range. Examples. First example is fx is equal to x. To find out the range, we consider fx to be y equal to x. Okay. Now here we see that whatever value of y we put, it is defined for all the functions. Whatever value of x we get, that will be the image of fx. Okay. So here range will be equal to set of all real numbers. Is it clear? Okay. Now we'll do one more example. Let's consider a function fx is equal to 1 by x plus 3. Okay. Now solution of this will be, let's consider fx. Let us write this equation as y is equal to, function as y is equal to 1 by x plus 3. Okay. Now we will make this in terms of y x plus 3 equal to 1. Now we'll open the bracket, yx plus 3y equal to 1. Okay. Here we'll express this equation in the terms of y. Yx is equal to 1 minus 3y, which implies x is equal to 1 minus 3y by y. On further simplification, we'll get x equal to 1 by y minus 3y by y, which is equal to 1 by y minus 3. Okay. Now we see that here whatever value of x we put, it will be defined except for one value of y, which will be which will make this function which will make this as undefined. That is, if you put y is equal to 0, then this will become undefined. Therefore, y cannot be equal to 0. Okay. Therefore, range of this function will be all the values of real numbers except 0. Is it clear? This is the process by which we find out the range of a function. Okay. Now we'll do one last example on range. Consider a function fx is equal to x plus 1 by 2 minus x. Okay. Now to find out the range, we'll consider this as y is equal to x plus 1 by 2 minus x. Now we'll simplify this. Y 2 minus x equal to x plus 1. Okay. Now next step, 2y minus xy equal to x plus 1. Okay. Now we'll make this as in terms of make the equation in terms of y, which implies we'll bring 1 to the left side and x to the right side, xy to the right side. 2y minus 1 equal to x plus xy. Okay. Now here we see that 2y minus 1, taking x common, x, if we take x common, we'll get x 1 plus y. Now we'll shift this 1 plus y here. X is equal to 2y minus 1 by 1 plus y. Okay. Now we get get this as 2y minus 1 by 1 plus y. Now we have to see that this function, this must be always defined. So for this to become always defined, 1 plus y should not be equal to 0. Okay. So here we see that y should not be equal to minus 1. Okay. Now the range of this function will be range of this function will be all the values of real numbers except minus 1. Is it clear? So I have solved 3 examples of range. I hope you have understood the concept of domain and range of a function. Thank you.